Well, hey kids, DadCode's back. Today we are going to be learning binary search. It's episode 3. This is the algorithm that finds stuff in a sorted list ridiculously fast. And we're going to go through 2 examples. They'll be coming up, so let's get to it. First we always like to start with some sort of a picture or teaching moment. And in this case, for binary search, let's see a phone book, picture a phone book, if you will. I guess I'm dating myself here. Ask your grandparents, maybe. When you're looking for someone, you don't start at the A's and read every name. You flip to the middle, see if you went too far or not far enough, and cut the book in half. Then in half again. That's basically binary search. Each guest throws away half the list. Big rule, though. The list has to be sorted for this to work. Okay. I got about 30 minutes while my kids are napping. So let's get started. I am already in DadCode on my external drive. We're going to be doing a ghosty terminal again today. I think eventually we'll move to VS Code when I get into my bigger projects. But for now, going through the algorithms in my first few episodes, I want to stay here just for simplicity. Or where are we? Okay, so we have episode 1 and episode 2. This will be episode 3, binary search. Cool. Let's create it. Episode 3. Let's make sure it's there, and we'll cd in. Awesome. All right. Let's create binary search.py. Okay, first example, the OG binary search. Find a number in a sorted list and tell me what position it's at. So what we need to do is define our function, binary search, nums, and then our target. Basically, function takes a sorted list nums, and the target, that's what we're hunting for. So we'll type left equals 0. These are our 2 pointers, left at the very beginning, right at the very end. And that's the length nums minus 1. These are our edges of where we're still searching. So that's why we have to have those variables there. And then we'll begin our looping. So we have to create a while loop. So while left is less than or equal to right. So keep going as long as those pointers haven't crossed. So less equal to right. We need to, sorry, where was I? Find the middle, right? So remember I said in the beginning, we are just basically cutting that book in half. So left, mid equals left plus right. And then we divide by 2. Cool. 2 slashes. That's integer division. So we get a clean index, no decimals. And then we have to start creating our conditionals. So we have to find the middle. And then we have to see if the middle, so if nums mid equals our target, basically if we found our target, set the middle, we're done. Hand back the index. Return mid. Return that value of mid. Else if nums mid less than target. So basically, if the middle is too small, our number must be on the right side. So you know your target, you check the middle. If it's not the middle, you check if it's smaller than the middle. If it is, it's on the right side. So we shove left past mid. So we go to the right. So in order to do that, we have to left equals mid plus 1. And then we just basically have our else statement here, which otherwise the middle was too big. Pull right back. And then right equals mid minus 1. And then to end our while loop, we return minus 1. So basically, if the return minus 1 is if we walked all the way out without finding it, basically return minus 1, and that's just like a universal not here signal. So let's do a test case. So we have assorted numbers that equal 1, 3, 5, 7, 9, 11, 13, 15. You can see they're all sorted. And then we want to print binary search, sorted numbers. Okay, so we're searching for 11 in 1, 3, 5, 7, 9, 11, 13, 15. We get back 5, which is the index. And we get there in 3 guesses, not 8. That's the power. So basically, our middle would be like, let's just say 9. It'll look at the target 11. 9 is less than the mid. So that means it's on the right side. So then what it does is it checks the right side. It does the same loop to get to 11, our target. Cool. So we should see the value of 5. 0, 1, 2, 3, 4, 5. 11 is at index 5. Let's save this. And let's run it. Python 3, binary search. Cool. Let's see, line 16, print, easy peasy. Okay, let's save that. Excuse me, Nano did. Okay. DadCode needs some coffee. 5. Oof. Hope you remembered that 11 was at index 5 after all that. Okay, that was our first example. Next, we'll do another binary search example. This is going to be a binary search to find the insert position. So we'll have to create a new file. So we'll call it binary search insert.py. So yeah, this example is example 2. It's a small twist. Instead of just finding a number, you tell me where it should go. If we wanted to keep the list sorted, super useful and a real interview classic. So let's get started. We're going to define a function. So same setup. We have insert position. We have nums and our target. Okay, and then we have to do left equals 0. And a heads up, we have right equals length of nums. And instead of length of nums minus 1 from our example, the first example, we need that extra spot at the end in case our number belongs after everything. So That's why you don't see the -1 in our variable. And we go through the while loop. So we loop while left is strictly less than right. So while left is less than right. Notice that it's not, it's less than, not less than and equal to. So that's another difference. So cool. So then we have to get our mid again, and that's going to be left plus right divided by 2. So same middle calculation as before. And we want to set some conditionals. So if the middle is too small, slide left past it. If num's mid less than target, we want to left equals mid plus 1. So we're sliding past it. Okay, and then we have an else because right equals mid. Basically, otherwise, and this is the trick, pull right to mid, not mid -1, because mid itself might be the right answer. So yeah, that's the little trick there that you'll see. And then we're going to return left. Okay, so return left, when the pointers meet, that meeting point is exactly where the new number should go. Okay, so for instance, we'll print a test case here, and then we'll see what happens. We have a list of our insert position 1, 3, 5, 7, and then we have our target of 4. So if we run this list of integers 1, 3, 5, sorted list of integers 1, 3, 5, 7, and our target 4, looking for where 4 belongs, answer index 2, right? That's between the 3 and the 5, which is, perfect. So it's looking for the insert position. Yeah, and let's save that and let's run it. And we called this binary search. .py. Oh, how are ya? Okay, so that's just position. So let's just nano back in. Cool. Save it. 3 goes in between 5. That's what we need. Sorry, 4 goes in between 3 and 5. That's what I meant. Python 3, binary search. Insert.py. The second position. Right, so it's nice that we have this error here because we get to see index 0, 1, 2, 3. Right, so if 4 was there, that's what the position it would be in. Binary search. Find it fast or find where it goes, really. This pattern does show up everywhere. It's part of like version control for bisecting bugs and even database, like looking up records, even some game AI, right? So I think in the next video, I have planned to tackle the, what was it? The Dijkstra's algorithm. I pronounced that wrong. Basically the GPS routing one. So please subscribe, so you don't miss it. And yeah, thanks for watching episode 3.